linear regions and inequalities. So here we're going to look at sketching some inequalities and shading in some regions on where those inequalities are true. The best way to do it is with a couple of examples. So the first example we're going to look at is y is less than or equal to x plus 1. And the first thing we want to do is when we're sketching a region is to just consider the actual equation. So y equals x plus 1, and that's what we want to graph or sketch. So sketching this out, we're going to have a y-intercept of 1 and an x-intercept of -1. And the line we're going to get is like this. And now we need to shade in the region that's true to the inequality. So it shows us all values of x and y that are true. Now, one way to think about it is it's asking where is the values of y that are less than or equal to the values of the function that we have, the line. So where are the values of y that are less than those values? So if we think about it, y values over here are bigger than the line, so they can't be true. But y values down here are less than the value of the line, so they have to be true everywhere below the line. If you weren't confident on just that, you could actually sub in a test point that wasn't on the line, for example 0, 0, and see if that point holds true. So if we tested 0, 0, we'd have 0 is less than or equal to 0 plus 1, so we get 0 is less than or equal to 1, which is true. And if you get a true value, it means it's true for all points in that region. So 0, 0 is below the line, so it's true for all points below the line. So then we'd go ahead and just shade in all that area that is below the line, where all the values of x and y are true there. Let's look at another example. Y is greater than 2x minus 4. So we want to consider the equation y equals 2x minus 4. And this is the one we want to sketch out. Now, when sketching inequalities and shading regions, one thing we do have to be careful about is what kind of symbol we have. And last time we had a less than or equal to symbol, so it was no issue. But if we have a greater than or just less than symbol, when we go to sketch our line or our function, we need to do a dotted line if it's a greater than or less than sign. So this is what we're going to do in this case. So we're going to have a y-intercept of -4. And an x-intercept of 2 here. But when we go to draw this line, and we have to do a dotted line because of the fact that it's just a greater than symbol. So we get a dotted line. And now we have to decide which region to sketch in. So it's asking for where are the y values greater than the values of the line? Well, they'll just be all the places above the line. But again, if you weren't sure, you could test in a value. Test 0, 0, because it's not on it. So we'd have 0 is greater than 2 times 0 minus 4. So we'd have 0 is greater than -4, which is true. And that means we can go ahead and shade in all the area above the line. Because 0, 0 was a point that was above the line, so it's true for all values above the line. So our last example, we're going to look at multiple inequalities and sketch the region that satisfies all of them. So we're going to look at y is less than or equal to x is less than 4, and y is greater than -3. So this means we need to consider y equals x equals 4, and y equals -3. We just need to be careful when we sketch them out with all the ones that are either greater than or less than as dotted lines. So those are going to involve these two here, because this one's greater than and this one's less than. So both of these need to be dotted, but this one has a solid line. So let's go ahead and put y equals x in first, which is just a diagonal line going through the origin. Now, x is equal to 4, just looks like going through 4. And because this one's just less than, it has to be dotted. So we get this function here. Then y is greater than minus 3. So we have minus 3 somewhere down here. And again, this one's greater than, so it has to be dotted as well. So we get all three functions graphed out like that. Now, which region are we shading in? This region here, this region here, this one here, in the middle. So we need to do a bit of an analysis on all the points, on all the inequalities. So where are the values of y that are less than or equal to the line itself? Well, that's everywhere below the line. So if you want, you can just put in a little arrow saying that our region needs to be below this line. Now, where are the values of x that are less than 4? Well, you can just think about it logically. 3, 2, 1, 0, all of these values of x are less than 4. So it makes sense that the region needs to be on the left side of this line here. And where are all the values of y that are greater than minus 3? Well, that's all these values above the line. Minus 2, minus 1, 0, all those values are greater than minus 3, so it needs to be above this line. And hopefully you can see that the region that satisfies all of those is in the middle of this triangle. Because if it was anywhere else, it wouldn't satisfy one of them. So if we did some shading over here, it would satisfy this, but it wouldn't satisfy this one or this one. Actually, it would satisfy this one, so it just wouldn't satisfy the value of x is less than 4. But so the region we shade needs to satisfy all three of these inequalities, which this one does.